In this ACT video, we're going to take a look at absolute value equations and inequalities. And when we talk about absolute value equations and inequalities for that matter, we always want to consider two possibilities. Okay? That's one of the big things you want to remember for these equations and inequalities. Let's take a look at a very basic example before we get started. And let's talk about the absolute value of x is equal to 3. What that means is, what that's saying is, what number is 3 units away from 0 on the number line? Okay, it's asking what number is 3 units away from 0 on the number line. Well, if we go to the right of 0, then x could be positive 3. And if we go to the left of 0, get our numbers up there, then x could be negative 3. So this is why we're considering two possibilities, because absolute value is distance, and so we have to think about traveling to the left of the 0 or to the right of the 0. So our solution set here would be negative 3 and positive 3. So we're considering two possibilities. Now, when it comes to solving an absolute value equation, the steps are the same as solving a regular equation. We just have to set up two equations. So when we set these up, the first one looks identical, 5x minus 12 equals 13. And the second one is 5x minus 12 equals negative 13. So a couple of points I want to make here. First of all, when you set up your two equations or two inequalities, this stuff inside the absolute value bars, notice that didn't change for either equation that we set up. So you never want to touch that. That's going to stay exactly the same. It's what it was equal to that we changed. We kept it equal to 13, and then on the second equation, it's equal to negative 13. All right, then our steps for solving are the same steps that you would use to solve any equation. You just want to add your 12 to both sides. 12's cancel. 5x is equal to 25. Divide by 5, and x is 5. That's one possibility. And the second equation, we're going to add 12 to both sides. 12's cancel. 5x is equal to negative 1. Divide by 5, and we get x is equal to negative 1/5. So our solution set is 5 comma negative 1/5. Okay, and remember we just use those braces to represent a set of numbers. The order that you write the numbers in the braces, it doesn't matter because it's just a list. Solving an absolute value inequality is similar. Here we have the absolute value of x minus 6 is less than or equal to 9. You're going to set up 2, because whenever you talk about absolute value, you always want to consider two possibilities. So our first inequality looks the same. You drop your absolute value bars. X minus 6 is less than or equal to 9. And your second one would be x minus 6. And not only are we going to change the sign of the 9, but you also have to flip over your inequality. So that's going to be greater than or equal to negative 9. So the second one gets what I call the flip change. Okay, flip the inequality, change the sign. Now when we when we solve these, solving the same steps, add 6 to both sides. The 6's cancel, x is less than or equal to 9 plus 6 is 15. The second one, we're going to add 6 to both sides. 6's cancel, x is greater than or equal to negative 3. Now there's some additional information we want to talk about with an inequality, with an absolute value inequality. And if we're to graph these on a number line, which you may be required to do on the ACT, we'd have negative 3 down here, maybe 0 right about here, and 15 here. All right, and the greater than or equal to negative 3, I'm going to do this in green, would be a solid dot because it's including the negative 3, and greater than or equal to goes to the right. Then, if we graph on the same number line, because we want solutions that satisfy this inequality, so you're graphing these on the same number line. Remember, your graphing on the number line is just a picture showing you what the solutions are. So x is less than or equal to 5 is a solid circle, and less than graphs to the left. Now, what we're looking at here is there's some overlap, and that's the only part that we're worried about. So we are concerned about this right here in between negative 3 and positive 5. So we want to take those little tails. Where's my eraser? Take those tails off. Those are not part of our answer. Okay? What we call this is an AND graph. This is an AND because there's overlap. Okay, we have ANDs and we also have ORs. An easy way to know that this is an AND is because this is a less than or equal to sign. So if it's a less than or equal to sign, it's an AND graph. In the next example, we're going to see if it's a greater than or equal to sign, it's an OR graph. So while this is not a real word, it may help you remember, okay, if it's a less than sign, there should be some overlap like this picture. If it's a greater than sign, we're going to look at that in just a minute. Being that the ACT is multiple choice, you want to remember some of these things so you can quickly eliminate some possibilities. Now, one more thing, you can write your answer instead of having these two separate inequalities. We can have x is less than or equal to 15, and then this would be less than or equal to negative 3 is less than or equal to x, which is less than or equal to 15. So that's one big sentence. So that's probably how you'll see it. And that also tells you it's an AND. Okay. Now let's take a look at the other situation with an OR graph. Here we have the absolute value of 4x minus 9 is greater than 3. Okay, so when I see that greater than sign, I think about this. You can say LAGO or you can say LUGO. It just helps me remember if it's a less than sign, it's an AND graph. It's a greater than sign, it's an OR graph. So I immediately know that this is going to be an OR graph, and we're going to look at what that looks like at the end. You still set up two possibilities. 4x minus 9 is greater than 3. Okay, you take off the absolute value bars. The first inequality looks the same. The second inequality gets the flip change. 4x minus 9 is less than negative 3. Again, I want to emphasize that the stuff that's inside the absolute value bars, we didn't change any of that. The only thing that we changed is the inequality and the sign on the second possibility. Okay? All right, now solving these, same steps as solving an equation or just a regular inequality. So 4x minus 9, we want to add 9 to both sides. 9's cancel. 4x is greater than 12. Divide by 4 on both sides. And x is greater than 3. Second one, we're going to add 9 to both sides. 9's cancel. 4x is less than negative 3 plus 9 is positive 6. Divide by 4 on both sides, and x is less than or equal to 6/4, which will simplify because 2 goes into 6 3 times and 2 goes into 4 2 times. Okay, so let's talk about the OR graph. All right, so let's put these two numbers on the number line. 3 over 2 is my smaller number because that's the same thing as 1.5 or 1.5. So let's put that number down here, and let's put 3 here, and then let's get a number in between, maybe 2. I know it's not exactly in between, but we want a couple of numbers up there just to show uh, what some of the solutions could be. And it gives some number sense. All right, so x is greater than 3. Greater than is just an open circle, and it goes to the right. Okay, and I'm using the same colors that I wrote in that associate with that answer, so you can make the connection. And then x is less than 3 over 2. That's also an open circle, and it goes to the left. So this is what an OR graph looks like, and there's definitely no overlap. So you can see anything in here in between the two is not a solution. Okay, there's no overlap in an OR. Again, it's an OR because it's a greater than sign or greater than or equal to. And when we write this, we would just write it not as one sentence like the and, it would just be x is greater than 3 or x is less than 3 over 2. So let's look at some ACT type questions you might see on test day, because there's some quick ways to eliminate some choices. Okay, so here we have, what is the product? That's important. What is the product of the solutions to the equation absolute value of 2x minus 3 equals 15? Okay, so ACT will love to do this type of thing, and they're not asking for an actual solution. They're asking you to get the product, which means you're going to multiply your solutions. So to solve this, it's absolute value, so we need to consider two possibilities. 2x minus 3 is equal to 15, and 2x minus 3 is equal to negative 15. Remember, the stuff inside the absolute value bars does not change. And we're just going to solve, add 3 to both sides. This gives me 2x is equal to 18. Divide by 2 on both sides. X is equal to 9. The second equation, we're going to add 3 on both sides. 3's cancel. 2x is equal to negative 15 plus 3 gives me negative 12. Divide by 2 on both sides, and x is negative 6. Now notice 9 is an answer and negative 6 is an answer. Okay, those are what we call good, wrong answers. And let's remember, though, the question asked for the product of the solutions. So we want to multiply 9 times negative 6 gives us negative 54. And so our answer is D. So be on the lookout for questions about what's the product or the sum of the solutions. That's pretty common. On this ACT question, we're going to use that LA Go that I talked about. It asks you to solve the inequality absolute value of 7x minus 5 is greater than or equal to 9. Well, immediately when I see greater than or equal to, I know this is an OR problem. If I look at my answer choices, the way A is written, this is an AND. So I'm going to eliminate that. B has the word OR in it. Answer choice C has OR in it. Answer choice D has OR in it. Answer choice E is written as one sentence, so this is actually an AND problem also, so we should eliminate that. So now we've at least narrowed it down to 3 choices instead of 5. Okay, now we're just going to have to set this up and solve. Keep the stuff inside the absolute value bars the same. The first one is 7x minus 5 is greater than or equal to 9, or 7x minus 5, and then flip change, less than or equal to negative 9. And we just solve. So we're going to add 5 to both sides. 5's cancel. 7x is greater than or equal to 14. Divide by 7. 7's cancel. X is greater than or equal to 2. The second one, go ahead and add 5 to both sides. 5's cancel. 7x is less than or equal to negative 4. Divide by 7. Sevens cancel. X is less than or equal to negative 4/7. All right, so I see I can eliminate B because that's got positive 4/7. And I can eliminate D because it's got a negative 2. And these answers are very similar to each other, so you want to be real careful by looking at your signs and don't get in too big of a hurry by marking the wrong answer by accident. So it looks like my answer is C. X is less than or equal to negative 4/7. That looks good. Or X is greater than or equal to 2. So absolute value equations and inequalities, you always want to consider two possibilities. If it's a less than sign, it's an and. If it's a greater than, it's an or. Let's look at one last example that you might see on the ACT. And in this question, it says x equals 6 is the complete solution set to which of the following equations? All right, so answer choice A is an equation. Answer choice B is absolute value equation, so it's actually going to have two answers when you solve it. Answer choice C is an absolute value equation, so it's also going to have two answers. Answer choice D is just a regular linear equation. And answer choice E is absolute value, and it also has two answers. So what they're asking us is x equals 6 is the complete solution set to which of these equations? Well, it can't be B, C, or D because those are absolute value equations, and absolute value equations have two possibilities. So it has to be A or D, so you'll need to solve those, and you can probably do that quickly in your head and see that the answer is A, 2x equals 12, because when you divide by 2 on both sides, you get x is 6, and that has the one answer, x equals 6. It's not D. Just to clarify why it's not D, that equation is negative x equals 6, and that means you divide both sides by negative 1, giving you x is negative 6. So I hope these tips helped you out. Try to eliminate possibilities to increase your time to answer some other questions on the ACT.